Hi, I'm Shelly and I'm a researcher and professor in the area of artificial intelligence. I teach AI concepts and algorithms to business management students, and hence my focus is absolutely on understanding, explaining the intuition behind these algorithms and where they can be applied, what are their limitations, what are their capabilities, etc. Since November 2022, ChatGPT really seems to have changed the way we think about artificial intelligence. Earlier, it was just something that, some computer science engineers and data scientists were doing. Now, everybody, I'm sure, has used ChatGPT or Bard or Claude for something or the other. Either you've asked it to generate an article or you've asked it to write an assignment for you, whatever. The point is, this technology is all pervasive. More importantly than our personal use is likely to be the business applications which are going to be possible with this technology. It is going to have an absolutely disruptive impact on business. So it is really important for business management students, and also if you're a business manager in general, to have an understanding of this technology and to understand its intuitions, limitations, and capabilities. But on the con side, it is a tough area. Artificial intelligence is not easy. It's heavily mathematical and very, very computer sciencey. That means there's a lot of coding and floating around. So it becomes a little difficult for people who are not from a technical background. Don't worry, this sequence of videos by me is going to help you in sort of understanding and decoding artificial intelligence and all the advanced concepts, and specifically with a focus on business application. In this video, I'm going to be talking about the first step in the process, which is to understand what these terms artificial intelligence means, and also relate it to other terms which are often used interchangeably, such as machine learning, deep learning, and generative AI. This is my channel, YouTube channel, AI Economics, where I have videos on, as I explained to you, on artificial intelligence and their business applications. Please do consider subscribing to it in case you're interested in this concept, and also hit the like button for this video. Artificial intelligence seems to be the flavor of the year. It seems when you read blogs and articles that there are many types of AI. There's AI, there's machine learning, there's deep learning, and now there's generative AI. And this makes understanding AI confusing for non-AI people, because do they all mean the same thing or are they different? This slide actually illustrates the difference. We can see that they are not actually the same, but they are related terms, as you can see. The overall term is artificial intelligence. So first, the overall circle is artificial intelligence, which at its simplest can be defined as a super smart computer program that can learn and act like humans, but is way faster and can process way more data. But that sounds quite clear, scary, I'm sure. Um, The inside the circle. So basically, AI is, think of AI as the like the human brain. It's the final thing which takes the decisions. Just as we take in a lot of information, and we take in lots of all kinds of inputs from different sources, such as visual, such as audio, such as text, and then we process it all together and then we make a decision. Similarly, AI represents that. It's a program that can sense, reason, act, adapt, and take decisions. So, I mean, that is essentially the term artificial intelligence. Now, machine learning. Machine learning is a subset of AI, as you can see. It focuses specifically on the learning aspect. So again, let me give a human analogy. Just as in humans, we learn skills, for example, We learn how to, we learn maths, for example, by practicing sums and then, getting them corrected and then learning the techniques. So similarly, machine learning is basically a case where the algorithm learns, learns from data, basically. The focus of the machine algorithm is to learn from data and improve its performance on specific tasks. So, unlike artificial intelligence, which is a little more generalized, machine learning is a lot more focused and task specific. A machine learning algorithm can be geared, for example, to understanding a particular aspect, or, for example, recognizing images, or it can classify objects, etc. So it's very specific and it learns from extensive amounts of data. There are various techniques for machine learning, such as supervised learning and unsupervised learning. We'll talk about these in a little while. And the goal is for the machine to be able to learn all the patterns in the data over time and then make relevant predictions for new data. So on the basis of artificial intelligence is then able to sit on top of machine learning to take decisions on the basis of patterns and predictions that the machine has identified. Now we come to deep learning, which sounds very fascinating. It again, as you can see, is a subset of machine learning. And it's a very specific type of machine learning inspired by the structure and functioning of the human brain. It basically sets up artificial neural networks in multiple layers, and these can be very, very dense. They can be like thousands of such layers. So you can imagine, and on the basis of these layers, the artificial neural network is able to learn extremely complex patterns. So deep learning is something which is very useful for learning complex patterns, such as in natural language. For example, text language is very complicated. Similarly, even identifying visual data, which is very, very complex, again, is something which deep learning excels at. Deep learning is extremely effective in all these areas. However, it requires a vast amount of data. The last and the baby in the field, but not going to be a baby for long, is what we call generative AI. This is a subset of machine learning, and it also, as you can see, intersects with deep learning. It's a specific area of machine learning focused on creating entirely new content like text, images, code, or music. Okay, you might ask the question, how does it differ from machine learning or deep learning for that matter? Machine learning and deep learning make predictions. They do not create new objects. They only can take data which is existing and identify patterns from it and predict the patterns. Generative AI can, on the basis of the predicted patterns, create new objects. For example, it can generate new images. It is trained on a huge number of images, and then you have a generative AI such as DALL-E, for example, which actually then proceeds to generate images. So generative AI is really useful for things like creating new content. It is likely to have a huge impact on product design, on marketing campaigns, developing personalized campaign content creation, and even on for content, image and content generation on the internet. So far, we've defined what is artificial intelligence and machine learning, etc. Let's now just deep dive a little more into what is artificial intelligence and what are the kind of characteristics of it. So the first characteristic that we can think of artificial intelligence, at least as of now, is that it's digital. AI exists as a software and algorithms running on computers and other computing devices. It can operate a physical entity such as a robot, but it is essentially a digital concept as of now. The second aspect about AI is the learning and adaptation. AI systems can learn from data and experiences. This can involve supervised learning, where, for example, they are actually learning from what we can call labeled data, or where the correct answer already exists in the data, and the algorithm is developing a mapping to figure out how to get the correct answer. You remember how we used to check the answers at the back of a maths at the back of the maths exercise and then go back and reverse engineer the answer. So that's exactly what is supervised learning. I mean, we were always told it was a bad thing, but it seems it's actually quite effective learning methodology. It can also learn using unsupervised learning, which is basically that it sort of finds patterns in unlabeled data. There are various statistical techniques which enable it to allow it to do so. This is definitely a more complex form of learning. On the basis of all this learning, it is then able to improve its performance over time and to adapt to new situations. That is to say, as data changes, so is the algorithm then if the scenario changes, then the algorithm starts adapting to the new scenarios. And this definitely is an example of how the AI is able to keep pace with changing circumstances. Continuous development. The field of AI is continuously evolving. I mean, it has been evolving at an exponential pace. And by the way, it's been around for a long time. AI algorithms were actually around, such as neural networks, etc., were around right from the 1950s onwards. So it is basically all the improvements in the algorithm specifications, the computing power, etc., which has enabled all this um, incredible, huge improvements in these algorithms. And this field continues to evolve at an exponential pace. Just 2 years back, ChatGPT was, basically something which was in beta in OpenAI. But now, I mean, it has virtually transformed the field of generative AI. So, I mean, and it will continue to evolve. So we will continue to see new techniques and capabilities emerging over time. Lastly, it also tends to mimic human behavior. So in some ways, though AI is not human, it tends to mimic human behavior. That is especially at the cognitive level. So for example, it is able to mimic human behavior in terms of natural language speech, or for example, the way image identification is done in our visual cortex. So these are all aspects which, for example, the artificial intelligence has already picked up. There are capabilities which humans have, and another important capability is generation of new text, for example, through generative AI. So these are all examples which the AI is mimicking human behavior through algorithms which are not necessarily the way the human brain processes, but it is achieving a somewhat similar result. What can it do? So where all do we expect to see huge impact of AI? One is in automation. AI can really help in automating vast amounts of data, repetitive tasks, where there's a large amount of processing of data, and this can really free up human capabilities. So this is one place where we can think of AI being an assistant, which really frees up human time and creativity for more creative and value-adding endeavors. The second thing is pattern recognition. AI excels at pattern recognition. So, I mean, with the digitalization revolution, there has been a huge and exponential amount of petabytes of digital data which is getting generated now. It is not possible for humans to analyze this data. However, AI can actually crunch this data and find patterns in it. So, I mean, being able to analyze this pattern is going to be a game changer from the perspective of utilization of data. So it excels in tasks like identifying anomalies, fraud, or even image recognition. AIs can analyze a lot of data and take decisions. So this is one fundamental thing. So examples of AIs taking relatively simple decisions is classifying emails into either spam or relevant emails. Another one might be recommendation systems such as the Netflix recommendation engine, which recommends very accurately, I might add, which films you can watch based on your preferences. Um, and lastly, the AI can help in problem solving. By analyzing data and by identifying patterns in data, it can develop solutions for optimizing problems and solving problems such as logistics or scheduling or maintenance of machines, etc. So there's a lot of ways in which AI can help us. Let's deep dive into what is machine learning. Let me first explain the concept very intuitively to you. Imagine you're training a puppy. You show it a ball and say fetch. You reward it with a treat whenever it retrieves the ball, and over time the puppy learns to associate the word fetch with the action of getting a ball. In a similar fashion, the machine learns patterns in a data to predict a particular outcome. Now let's just try and understand what does data mean and what does outcome mean. Let's understand this best. This is best understood with a simple example such as diabetes prediction. Suppose you're a hospital and you have a large amount of patient level information, and you want to use this to have an algorithm which will be able to proactively predict whether certain patients are more likely to get diabetes. So in the data set, what do we have? We have the outcome variable, which is basically whether a patient has diabetes or not diabetes. And associated with each patient, we have certain other data points such as their weight, their BMI, their blood pressure, their fasting blood sugar, etc. Now, given these data points, so this basically represents the data, and we have the outcome, which is diabetic or not diabetic. Now let's go over to this to understand what is the machine learning process. Now, the data set that the hospital has will consist of several thousand rows of both the data points associated with each patient and whether they are diabetic or not diabetic. The first thing we will do when we are training an algorithm is to split the data into two parts. One is your training data and the other is your test data, which is used for evaluating the algorithm. With the training data, we will use various statistical algorithms to try and learn patterns to predict whether the patients are diabetic or not diabetic. Once the model has been developed, this is then applied on the test data set. We then compare the predictions of the model with the actual labels of diabetic or not diabetic. If the two match at a reasonable level, that is to say there is reasonably high accuracy in prediction, we go ahead and we use the model and we deploy it to production. If it doesn't, we go back to square one and we retrain the model. Maybe we add on more data points or we add on more data and retrain it. Once we have our model, what do we do with it? The hospital will then take an input of fresh data, where it will input only data for new patients, but without the outcome variable, and it will get a prediction. whether this person is likely to be diabetic or not diabetic. And we will be able to say that whether they will be diabetic or not diabetic with a certain level of certainty. I mean, maybe the algorithm is 90% accurate. So we can say there's a 90% accurate chance that this person is predicted to be diabetic. So this is how a supervised machine learning model works. Machine learning is extremely useful in learning patterns over large data sets. When you have big data, it can be extremely useful to use a machine learning strategy to learn the patterns to predict data. It also automates tasks that are repetitive or require processing large amount of data. All right, and briefly, supervised learning is one major algorithm, and there is unsupervised learning also, which is essentially where we do not have the outcome data, we just have your data points, which is, your BMI and your whatever, and we try and find patterns in the data. This kind of learning is definitely more advanced but and more challenging. However, in the real world situation, in most scenarios, we don't actually have data. We don't actually have outcomes. We only have the data. So therefore, that is one of the reasons why unsupervised learning is used. So this in brief was basically a little bit about machine learning. Now let's understand what is deep learning. Deep learning, as we know, is a subset of machine learning, but it makes use of a very specific kind of technique. First, let's understand it a little bit at a very high level intuitively. Suppose you're showing a friend of yours photos of different dog breeds. At first, they might just seem like a bunch of fluffy animals. But as you show them more and more pictures, they start noticing different features. They may notice that there are floppy ears for bloodhounds, pointed ears for German shepherds, and short snouts for pugs. This is kind of how deep learning basically works. Deep learning is a specific type of machine learning which is inspired by the structure and function of the human brain. It uses artificial neural network with multiple layers, much like the interconnected neurons in our brains. Let's understand this with respect to a small and very simple neural network, which is picturized over here. The circles represent each cell or neuron. So in the input layer, there's various input data, one data point per cell. Then there are what are known as hidden layers. These contain various neurons and there are various hidden layers. And as you can see, there is very complex processing which is going on because data is being passed from each of these cells from one layer to the next layer. This is very complex processing. And finally, there is an output layer which will then give some outcome variable, such as whether it's a specific breed of a dog. In reality, this is a very simplified version. In reality, there are hundreds and thousands of cells in a particular layer, and there are thousands of layers as well. So you can imagine the level of processing that happens in a deep learning model is very, very complex. It is also very data intensive. Each layer processes information from the previous layer and becomes progressively more sophisticated in its understanding of the data, which is very similar to the idea that as you keep looking at the photographs, you started slowly being able to identify that bloodhounds were associated with floppy ears. This allows deep learning to identify complex patterns and relationships within data, especially large amounts of data such as images or text or audio. So these are all places where deep learning is used. Deep learning is very powerful but it also requires a huge amount of data. So that's basically the con associated with deep learning. Deep learning is the basis, the fundamental basis of natural language processing, and it's also the fundamental basis of image identification, image identification. So these are two major applications of deep learning. So now what is generative AI? We finally come to the most exciting aspect of artificial intelligence, which is generative AI, which is basically what is known as ChatGPT, for example, or Bard or DAL-E. These are all examples of generative AI. Now, generative AI is a subfield of machine learning that focuses on generating entirely new content like text, images, music, or even code. Imagine writing a poem in the style of Shakespeare, but you want to incorporate modern technology references. Generative AI can attempt this by analyzing various existing poems and creating something new that reflects both styles. It can also design a new product prototype based on existing data about customer preferences, or it can create a personalized marketing campaign for each customer. So generative AI is hugely exciting, and as you can see, there are massive corporate applications to it. Um, Generative AI models are trained on massive data sets of existing content. For example, ChatGPT has been trained on almost 450 gigabytes of data. So that's just one estimate of the kind of volume of data that it's trained on. Essentially, it functions by analyzing patterns and relationships within this data. They learn the underlying rules of how things are created. The model then uses this knowledge to generate entirely new content that resembles or expands upon the data they were trained on. So it is a huge kind of exciting kind of area which can be used to generate text, images, code, music. Generative AI is still under development. So it's something which we're going to see growing in its potential. However, it has already demonstrated huge potentialities and in terms of applicability for designing new products, for generating text, and for personalizing marketing campaigns, etc. So this is really exciting. I hope you found this video engaging. Please hit the like button as it helps with the algorithm. Also, please subscribe to my channel AI Economics and hit the bell icon to be notified about new videos. I will be coming up with new videos and content relating to simplified understanding of artificial intelligence and generative AI. Thank you.